Delta learning is a powerful concept that inspires many works of machine learning and computational chemistry. The idea is simple. Add a mal correction to the prediction of the baseline low-level QM method to approximate the target high-level QM method. Think about correcting semi-empirical methods to the quality of coupled cluster. This is exactly what we have done in the AI QM1 method. Delta learning is slower than pure machine learning models, but the benefit is typically an increased robustness and accuracy. Here is an example, where delta learning model AI QM1 gives correct bond length in full ring, while the pure ML model Ani1 CCX fails. The price to pay is that delta learning models are slower than pure ones. You can learn how to construct such robust delta learning models in our online tutorial. If you want to learn more about AI-enhanced computational chemistry, you can check out my new hands-on online mini-course, perfectly suitable for both beginners and experts wanting to upgrade their computational tools.